Hello, everyone, and welcome. This is Adil, OPA business developer, and welcome to this drilling session titled Drilling Optimization and New Drilling Technologies and Applications, presented by our instructor, Engineer Safwat Al-Ghazali, who holds an oil production diploma from Cairo University. He is also a graduate of Suez Canal University by 2000. As a petroleum engineer. Engineer Safwat is a certified SPE professional petroleum engineer since 2017. He joined oil and gas industry in 2003. After that, he worked in many local, international, and service companies inside and outside Egypt, like British Petroleum, Aramco, and Edison. He has a wide range of drilling, workover, and completion experience. He also has a dual skill between rig site as a well site leader and office as a drilling engineer. He has a wide skill in drilling shallow, deep wells, in addition to deep water drilling knowledge. And now, Engineer Safwat, the mic is yours. I hope you enjoy this session today.
Thank you very much. Appreciating your just brilliant introduction. And I hope the session today to be exceed our expectation, inshallah. I'm seeing that the number of attendees have exceed 30 candidates.
Yes,
right?
that's because they are interested in such topic.
To have a participation. Yes. Let we have a conversation. You make all of them mute, yes?
Yes, but I can unmute them if you want.
Yes. Yeah, if you can give them a privilege for participation and they have the possibility to make a mute, because I need to listen from the beginning from their side.
Okay, 1 minute.
No problem, take your time.
Okay, they can unmute themselves now.
Okay, team, I'm planning today to have for 1 hour. So I appreciate if I'm listening from your side. If you can introduce yourself in your name and what is your expectation from this hour. We can start with volunteers. Who could start, or I could select? We can alphabetical. We have Adika, Ahmudu. So I need to listen to you at the beginning. Any volunteer? Anyone that will start? My question is, what is your expectation for today?
Hello.
Yes, I'm here. Who is talking?
Ahmadu Habib.
Welcome, Ahmed. What's your expectation about today?
Maybe if there is a practical, I think it will be very good for me.
I think we have a bad internet connections. Amir. Sorry, Ahmed, we hardly hear you. You could start, Amir.
Hello,
Okay.
hope you are fine.
Hello, Amir.
I think today we'll talk about type of mud we might use in drilling, bits, what type of bit, and if we reach specific formation, what we shall do, like shale or something like that. Maybe.
Yes, we are talking about the drilling problems. Yes. Fine, it's good. What else? What after Amir and Ahmudu? Any other volunteer? Guys, folk. Who need to participate at the beginning?
Hello.
Alaykum assalam wa rahmatullahi wa barakatuh. This is Emmanuel or Shahab?
Shahab Ali, sir.
Shahab? Shahab?
Yes, sir, Shahab Ali.
Fine, Shahab. I'm listening. And in fact, all of us are listening. Go ahead.
Sir, I complete my grade. Sir, I am geologist. Recently, I completed my graduation in geology.
Fine. Good.
Sir,
Great.
today's session is my expectation is that I will get to learn something new, and that I will gain more information about drilling.
Good. So I expected that
Yes,
we
sir.
have a combination between engineering and the geologist. We have multi-disciplines between the audience.
Yes, sir.
Fine, fine. You are welcome. You are welcome, Shab.
Thank you, sir. Thank you.
Who else?
Hello?
We have Ibrahim and Karim from the Zoom chat. Ibrahim said that we will talk about RSS. And
Oh,
Karim said that we will talk about drilling problems during lost circulation, partial or complete.
fine, fine. But he go direct to RSS, root restore system. Good, good. What else? Yes, my question is for Noor. I'm talking, what is your expectation? I'm doing that for what? I'm doing that to break the ice. I need to be
Hello?
familiar with. Yes, hello?
Hello?
Let me
This,
repeat
this,
my
this is
question.
Emmanuel. This is Emmanuel.
Hold on, Manuel. Just a minute, Manuel. Just a minute. I need to repeat my question again. My question
All
again
right.
is all the audience that what is your expectation from this hour? What would you like to hear from my side at this hour? Already I have prepared the presentation, but it could be another and supplementary for that. So I need to know what is your expectation about this series of drilling seminars. Okay, Manuel, you can join us now. You can talk
All
now.
right.
Go ahead, please.
Good evening. This is
Good
Emmanuel
evening. From where you are, Manuel?
from Nigeria.
Yes, good. You are most welcome.
Okay, so my expectation this evening is to learn about drilling technology,
Good.
the new technologies that are involved in drilling processes. So I want to know more about it from this class. I want to be enlightened about the drilling technology, the design, and the rest. Thank you.
Welcome. What's your background, Manuel?
Okay, petroleum engineering.
Good. Fine, fine. Have you graduated or not yet?
I've graduated.
How many
I'm
years?
currently working as a smithing operator.
In Nigeria?
Yes, in Nigeria.
Fine, fine. Good, good, good. And I have in the chat Muhammad Alamin talking about extended reach drilling, ARD. Fine. Any additional participant? Fine. We will try, inshallah, to cover all these points, not in this time, but I think could be another meeting, inshallah. Now we will start. We will, first of all, for not making any interruption for our colleagues who are interesting and are focusing in this seminar, I eager all of you encourage you to make all your mobiles silent and to make your phones are mutes unless you want to ask a question. And feel free to ask a question at any time, because when we finish at the end of this seminar, I have limited time to answer questions. Next, I am in all my courses, I'm trying to emphasize that the golden goal and the golden key for success is working as a team. Team have a multiple power, and you need to keep in your mind that Superman and Batman and in other series, Spider-Man are not found in the reality. They are in Hollywood and in movie only. So to have the success and to achieve your ultimate goal, you need to work with your members as a team. No individual work will achieve what is a teamwork will achieve. So be ready. That is the era that we are entering and that we are working today is a teamwork. A teamwork can achieve every goal that individual work couldn't achieve. Now we will talk about an overview of drilling engineering because we have multi-disciplines from different working branches. We will talk a little bit about the life cycle of any well. Any well have a life cycle. We have the first, the design. We have the drilling phase. We have the testing phase. We have a completion phase. We have an operation phase. We have an intervention phase. We have an abandonment phase. And this is for every well. And in fact, we have also a life cycle for a field. A field is consist of many wells that have been drilled. And we will see together what is the different definitions of each well classification. We will see that we have a wildcat well and an exploratory well, in addition to a development well and infill well, and by the end we have a water injection and water source well. Every well have this life cycle. Let's start with design. We are making a design for our well. Then we drill the well, which our talking today, we are focusing about the phase of drilling of any well. And the drilling is consists of many ultimate different parameters when they are connected together, make a drilling optimization. After that, we will test the well to ensure that this will either have a hydrocarbon in place or doesn't have. And if we have a hydrocarbon in place, either gas or oil, we will complete the well to start production. While we start production, we will have in the life cycle of the well many intervention, and we have intervention operation and workover operation. Anyone know what is the difference between the intervention operation and the workover operations? I have a question for everyone that listening for me. What is the difference in your mind, in your thought? You need to guess what is the difference between intervention and workover. Any volunteer? When I could say that this well, this operation is classified as an intervention operation, and this operation is classified as a workover operation. Who could answer or who could guess for this? I will tell you. Intervention operation is different than workover operations, although they can use vice versa, but intervention operation is the expression when I am not in need to nibble down or to release the Christmas tree and nibble up and to use the BOP. So if we are talking about putting a plug, retrieve a plug, perforation through tubing, plug through tubing, tubing batch, if we are talking about that, BLT, all of this operation is called well intervention. Regless frac, which is considered one part of stimulation because we have stimulation at the frac operation and acidizing. If we are making acidizing, if we are making a frac without the need to release or to nibble down the Christmas tree, it's called an intervention operation. If we need to nibble down the Christmas tree and nibble down the BOP, it's called a workover operation. If we need to retrieve the tubing, it's called a workover operation. If we have a short in an ECB, for example, and we need to pull out all the string, it's called a workover operation. This is a slight difference between intervention operation and workover operation. And as I have said, we can use the same expression for the other and for the same operations. No problem for that. And at the end of any well, like the human life, we have the abandonment, and we have abandonment, permanent abandonment, and temporary abandonment. We are talking here for permanent abandonment, that we will leave the well forever, and we will return to enter it again, and we will resume the environment as it is at the beginning as we can. Drilling optimization, what is it? Drilling optimization is for, we have horizontal wells that go like that, and we have vertical wells. And horizontal optimization is a conjunction between all of these items. We have for drilling optimization, we have drilling parameters, we have base selections, and one of our colleagues, one of our team have been said that he need to know about that. We have well bore positioning, we have well planning, we have process, we have technology, we have geomechanics, geoscience, rig selection, and the casing liner drilling, mud engineering. One of our colleagues expected that we will talk about mud, but in fact, the short time doesn't give the opportunity for us to talk about mud. We have pressure management. We have pressure drilling while we have pressure management drilling while management while drilling. BDM. We have ECD, equivalent circulating density management. We have performance drilling. We have drilling engineering. We have motors. One of our colleagues mentioned in the chat and mentioned that I think in Ibrahim, that he need to hear about RSS. One day we will talk about, inshallah, about retrievable steerable system and what is the advantage that he add for motor. And I think we will today, inshallah, we will see a video related to positioning of a well, and it have a direct link with RSS. And we have drilling dynamics, and we need to know the pressure losses in the annulus and the pressure ratios in the tubing. We need to talk about the whole cleaning. All of them, all of these items are linked together, and we have the tip top of each one. At the end of the day, we can say that we have a drilling optimization. But if any of these ones or more than one parameter doesn't we have the most expected variable of that, so we have as a beach of drilling optimization. The well planning objective, we have three main objectives of drilling a well. We need a safe well. This is top of the top. This is the priority of any operation to be done in a safe manner, in a safe situations. We need every worker to return to his home safely as he left it. We need to do that with minimum cost, and in fact, we need to drill the well to be a usable well. Keep in mind, and your mind, that we are not drilling for just drilling. We are drilling to have a hydrocarbon. The drilling itself is a tool. It is not a goal. The goal of the drilling is to reach a reservoir and to make the money machine start and return revenue and benefits for all the shareholder, for all the stakeholder that expecting to have revenue and profit from this operation. We are not drilling for just drilling. We are drilling to have a hydrocarbon, as drilling is a tool, and the ultimate goal is to have a hydrocarbon and to have a successful business. So we are planning to have three objects. The first of them and top of top is the safe. The second one is with dealing with minimum cost, and we excluded the expression of cost reduction. We are using the expression of cost optimization. And because in some time reducing the cost have a side effect in the operation itself, and it can't be considered a cost optimization. We replace the cost minimize by the expression of cost optimization, and it goes without saying that we are drilling a well to be a conduit for hydrocarbon. The drilling optimization, it's a systematic approach. First, we need to identifying the issue and determining a course of action that will be taken, then applying appropriate technology and establishing a feed loop. This loop is dynamic and it is in continuous manner. As Baker Hughes, John Ropes said, we can't improve efficiency and reduce NBT. For who not know what NBT is an abbreviation for non-productive time. Reduce NBT and improve risk management in isolation or simply by twiddling. It can't be achieved by isolation or simply tweaking one drilling parameters. We should play for all the parameters in all time. We should have the peak of each one. For example, and this is a famous example, a turnkey drilling contractor began to drill 9,000 feet well in September 1979. The well was in a high activity area that they have drilled before 52 wells in a township, approximately 36 square meters. The contractor was reputable and had a successful history. The drilling superintendent is the person who are responsible for multi rigs, and he is sometimes in the field and many times and the usual time to be in the office. Called a bid company and obtained records on two wells in the section where this is to choose the best bit to drill these sections of this well. The prospective well was to be drilled. Although the record was approximately 15 years old, it appears that the formation pressure would be normal to a depth of 9,800 feet. We have a normal formation pressure, which is slightly 0.4 4 psi per feet, and the gradient, and the freshwater gradient 0.433 psi per feet. And more than this is abnormal pressure, less than this is subnormal pressure, and both of them have its related drilling problem. If we have abnormal pressure, so problems related to well control, and we have a kick, and we is most likely, and if we have a subnormal pressure, the drilling problems related to low circulation is most likely to happen, and we need to take this in our mind. So in this area, he found that the pressure is normal. Since the prospected well was to be drilled to 9,000, the pressure problem was not anticipated. Why? Because the problem started at 9,800 feet. The contractor elected to set 934-inch casing to 1,800 feet and use 9.5 pound per gallon mud to 9,000 feet in 978 hole. At that point, responsibility would be turned over to the oil company. During was uneventful until a depth of 8,750 feet was reached. At that point, a severe kick. We have a kick here. This one, a severe kick was taken. An underground blowout occurred. I have a question. What kick means? Any volunteer to answer? What is the word kick means? Do you know what is kick?
Yeah, sir.
Yes.
Yes,
Go
right.
ahead.
Servo an unwanted fluid flow into the valve, known as kick.
Yeah, fine. Fine. Good. It is a mandatory for the cake to have a density or specific gravity less than the mud, or could be more than that. Okay, good for the definition. Good. An underground blowout occurred. If we couldn't control the kick, and we have barriers in the well, we have a static barrier, we have fluid barrier, which is the mud, and we have a mechanical barrier. Any know what is the mechanical barrier while we are drilling? The BOB. BOB is the mechanical barrier. That if the fluid barrier failed and couldn't control the kick, so we are forced to use the mechanical barrier, which is the blowout preventer, abbreviated by BOB, into the surface blowout. The rig was destroyed, and the consequences for any blowout is very severe, and natural resources were lost until the well was killed 3 weeks later. Okay. A drilling consultant returned by a major European insurance group conducted a study that yielded the following result. A well in the area appeared to be normal pressure until 9,800 feet. However, 4 of the 52 wells in the specific township and range had blown out in the past 5 years. It appeared that the blowout came from the same zone as the well in the question. So we have a 4 years, 4 wells that have the same experience and have been kicked before, but they have ignored them. A total of 16 of the remaining 48 wells had taken kicks and severe gas cutting from the same zone. Conclusion that I need to focus. The drilling contractor didn't research thoroughly the surrounding wells in an effort to detect problems that could endanger his well or crew. The final statement by the insurance company was over a 6 million. The incident probably wouldn't be having occurred if the contractor had spent only $800 to obtain proper drilling data as the drilling consultant had done. The drilling planning objective is to complete the story. We don't need to ignore part of the story and focusing in another positive one, because in fact we will affected with the negative part most likely higher than the effect of the positive one. We need to make the story harmony. If we collected data and ignored another data, the data that may be ignored, that will cost our project severely and may damage the project itself and cause harm to the people and fatality and energy and make the business model and the business job for that to be failed. So I need all of you to make all the parts and all the data together. And to keep in mind that as much as you will spend in well planning and as you will do more efforts in well planning, as the well cost will be decreased. As you spend for well planning effort, as the cost for sure will be decreased. And you need also to keep in your mind that mistakes are painful when they happen. But years later, a collection of mistakes called experience, which leads us to success. Now we will talk about characteristics of well type. We have, because you will hear these exhibitions and types of wells while you are working. You will hear about wildcat. Wildcat is the well which drilled in and concessions for the first time and doesn't have an offset wells. You will make a discovery for the formations and the parameters of the formations and the fluid in these formations and the pressure related to this formation, and either it is a problematic one or not. This is the wildcat well. And this is exactly like a cat that lives in a forest. His action is not unexpected. The rank number 2, which is less risky, is the exploratory well. It's exactly like the wildcat, but we have an offset wells, but it is far away from this well that will be drilled. If we drilled an exploratory well and we found a hydrocarbon in this well, so we need to know the extension of this reservoir. We need to know the volume of this reservoir. So we need to drill a step out well. In other definitions, it's called an appraisal well. We need another well away from this exploratory well to know the extensions of the reservoir and the hydrocarbon bearing formation. In between, you will find that there is a well will be drilled to develop this concession, this reservoir, which is called infill well. And if we need to enter an existed well that temporarily abandoned and go for another reservoir, this is a re-entry well. And we also have a classification for wells from the risk perspective. We have high risk wells, we have medium risk wells, we have low risk wells. The high risk wells, like oil gas wells or exploration wells, we now know what is exploration wells mean. High risk wells are oil wells of H2S content of 10,000 parts per million or more. I have a question for the team. What is the permeable allowed percent for working in of H2S? Any idea? What is the accepted H2S percent?
4
Now,
to 10 ppm.
who? How much?
4 to 10 ppm.
40? Could you write it in the chat? How? What is the value?
0.5 ppm.
4 to 10. No, I'm talking about the maximum. It is not 4. Mahmoud said that it's 10. 4 to 10. It is not 4, but it is 10. It is accepted to work. The maximum value that accepted for worker to work for 8 hours continuous is 10 ppm, not exceed 10. We are talking about the H2S is the silence killer. Silence, because at a certain concentration you will lose your ability to smell. So it is exist, but you don't feel it. So the maximum value of ppm of H2S that workers can work is 10 ppm and can work for 8 hours only. Returning back for high-risk wells, oil wells with an anticipated shut-in wellhead pressure, SIWHP, is shut-in wellhead pressure of 3,000 psi or more. Oil wells located within 1,000 meter, 1 kilometer or less of a populated area or public highway is a high-risk well because the consequences of that population is very high. Wells requiring workover in which integrity is suspect. Wells with sustainable analysis pressure into 958 casing or 1338. It's high-risk wells. Now we will talk and give examples for the medium-risk wells. Oil wells, drilling or workover, capable of sustaining natural flow to surface. And oil wells with anticipated shut-in wellhead pressure of less than 3,000 psi. And oil wells contain H2S less than 10,000 parts per million. Now we will talk about the category C, low-risk wells. Wells of any type that are not capable of sustaining natural flow to surface, which are called in production is depleted. Oh, shut-in wellhead pressure. We have Noor asking about shut-in wellhead pressure. Shut-in SIWHP is the shut-in wellhead pressure. If we have a well and we close this well and we measure the pressure at the surface, so this value at this time is called shut-in wellhead pressure. I will try to explain that. Let we say I will try to share with you. So, if we have a well, okay, let we say this is the formation and have been perforated, or this is an open area, and we have a pressure which here let we say 5,000 psi. And we have a drilling fluid that give us here the pressure equal 5,500 psi. As this situation, does it called if I'm drilling this well and I have a hydrostatic pressure B hydrostatic equal this value, and the B formation equal this value. If this my drilling situations, I called it overbalanced drilling or underbalanced drilling or balanced drilling. This is the question. This situation, having this one, so I have overbalanced press. Great, Ahmed, great, Ahmed, and overbalance. Diala, good. Good. Fantastic. Noor, overbalance. Good. Good. Emmanuel, I'm so much happy with your participation. Right. This is exactly overbalance drilling. So if I put a pressure gauge here, let we say, imagine that is closed by the OPA or the Christmas tree if we are in production. And I have a pressure gauge here. This is 0. This is 100, 200, until 1000. So my expectation for the pressure reading in this gauge to be what at these situations? If I'm measuring here 500, Amir, no, I'm sorry to tell you, Amir, this is the 500 for the coming example. We're expecting to have 0 here. Why? Because all the pressure that facing the formation is more than formation with 500. What if, so we'll read here 0, and at this time shut-in will head pressure will equal to 0. Shut-in because it is static, not dynamic, not flowing. Shut-in. Wellhead, this is the area of the wellhead. Pressure, this is the reading of the pressure gauge. Okay. What if we make, let we have this, let we make this opposite, and we make this one like that. If we choose, and the pressure at that time of the formation is 5,500, and the pressure of that hydrostatic pressure is only 5,000. At that case, when we have 5,500 formation pressure, and we have hydrostatic pressure for the drilling mud and drilling fluid is 5,000. This case is called overbalance or underbalance?
Underbalance.
Exactly. It is the opposite. Suhail, Noor, Dila, Emmanuel. Right. In this case, to have underbalance, good. In this case, my expectation and our expectation for the shut-in wellhead pressure will be how much? This value will be how much? This gauge will read how much? Emmanuel, 5. Nej, 5. Yes. All right. So we will find that it will read for 5,000. So the shut-in wellhead pressure will be 500 psi. It is the difference between the formation pressure and the hydrostatic pressure. In this case, as you have mentioned, this is an underbalance situation, and it could lead to influx. The formation fluid will enter the well, and this influx will lead to a kick. And if this kick have not been controlled by the mechanical barrier, which BOB, we will have a blowout, which is not desirable. And we are taking all the measurement and all measures to stop this. I hope the expression for shut-in wellhead pressure to be clear now. Okay, Noor? Noor have asked for shut-in wellhead pressure. Stand for what? Yes. Okay, Noor. Good. Let we complete. We talk about the high risk, minimum risk, low risk. I need to show you that learning curve. This is in general and in drilling specific, as we are talking about the drilling, the learning curve with time is increased. Our goal is to drill our well to the TD total depths with the minimum time. You will find that with your well number one, you take much time to reach the same depth. This is the depth. Y-axis is referred to the depth, and x-axis is referring to the time that you have reached this depth. You will find that will one number one take from your side long time, and is the longest time to reach the same depth more than will two, and will two have reached the same depth with less than time of well one and well three and well four, because your learning curve is being enhanced by drilling wells. Now we will talk about well design strategy. Role of well design strategy. Well design strategy determines the basis from which casing and tubing design is performed. The success of a drill well is largely dependent on the overall strategy that was selected during its planning. Thus, careful consideration of the intended and forcible use of the well is important and should be tempered by the desire to minimize cost and risk. We should take in our mind the category of our well. We have normal category, we have HPHT, which stands for high pressure, high temperature wells. We have ultra HPHT wells, and this is the specific cutting edge for each type of HPHT wells. This is the static reservoir pressure that you are facing, and this is the reservoir pressure that you will encounter, so on. We need to know in our mind what is the strategy, what is the purpose, what is the objective of the conductor pipe, what is the objective of the surface casing and the intermediate casing, in addition to the production casing, and for sure the tubing which is used for completing the well. Conductor and structural casing, this is the function of the return mud to the rig offshore or raise mud return above the shell shaker, provides a means of controlling artesian flow or shell isolate. Conductor is the main purpose to put a type of well control equipment which is called diverter. You need to keep in mind that we don't use the BOP with conductor because conductor have a shallow depth and will not be able to sustain this high weight of BOP. So we are using diverter, and the function of the diverter is not to close the well. The function of the BOP is to close the well, but the function of the diverter, like its name, is to divert the shallow gases that we are encountered in the shallow depths into a safe area away from our rig and to be flared. Because if we shut in the well at shallow depths, we will have underground blowout because the formation is friable and the formation strength is very weak. The formations are very weak. And we have, this is the function for the surface casing. I expect that you have learned that while you are being tested for drilling, and although also for the protective and intermediate casing. I'll go for it in a hurry. And the production casing, this is the last casing that being used in the well. In addition to the tubing, we should use the proper selection for the tubing for the proper production. And the tubular design consideration, we should take in our mind that the well function, is it a production oil or gas well, or it is a water injection well? We need to take into our consideration the corrosions. We need to take into our consideration the flow rates, the well depths, the whole angle, the pressure, the temperature, the corrosion, the erosion. What is the difference between the corrosion and the erosion? Any idea what is the difference when I say that this is a corrosion and this is an erosion? Any idea? The erosion is related to the surface velocity. And it is not a chemical interaction. Corrosion from outer, corrosion, there is oxidization, yes. Good, good. Corrosion is a chemical reaction. Is a chemical reaction for the steel. But corrosion is like abrasive. We have an abrasive material with a velocity that go for the surface and make it eroded with abrasive material. For example, for gas wells, if we are producing sand with high velocity, or for oil wells, sand with high velocity could lead to a corrosion, could lead to, sorry, for an erosion, lead to for an erosion, not a corrosion. But if we are producing H2S and CO2, or producing water with a high salinity, this could lead for a chemical reaction that resulted for a corrosion. And erosion and wear is like each other. Well locations, we need to take into our consideration the well location, type, size of drilling rig, well life, economics. Source of well data, we have sources for well data from geology, from the reservoir engineering, from subsurface engineering, from drilling engineering. Geology, responsible geology is responsible for combining geophysical and offset well data with geology that determines the best location for a prospective well purpose, knowing the purpose of the well, because we have a geology with our team now. Knowing the purpose, he should know, and I expect that he know more than this. In knowing the purpose of the well, whether it will be an exploratory, production, replacement, outpost, disposal, injection, appraisal, is necessary to determine the risks and conditions that must be considered for the drilling and tubular program. Geologic target, know it very well. This is the matrix for the source of the data. Who should give us what? If we are talking about abnormal pressure, the source for that will be the geology. If we are talking about bit size availability, the drilling department and drilling folk will be the responsible for that. If we are talking about bottom hole pressure, the reservoir pressure will then. If casing size, setting selection, the drilling will be responsible for that, and so on. Well planning. Well planning is an organized process used to put together data that will be used to design a successful. A well plan is a very important stage prior to the commencement of a drilling operation to ensure that all aspects are tailored to meet the specific objective of the well. Understanding how to design a well plan is one of the most important duties of the drilling engineer. He must be able to understand the plan and make any required changes. It should be dynamic. The data provided is used by the well planner to develop a geometric profile for the safest, we are talking about safe every moment, safest and easiest path from the surface location to the target. The planner has access to a computer program to help develop the best possible profile. Like if we are talking about computer program like well planning package, we are talking about stress check. If we are talking about direction, we are talking about the program called Compass. This is related to Haliburton, and so on. The need data is put into the program so that the well profile can be printed, plotted, and used for the drilling project. And we, in a daily basis, in every survey, we are comparing what is the actual between what is the plan. And if we need to correct our trajectory, our actual data to be like the plan, we make a correction for that. Components of a well plan. We are talking about surface locations, target location, kickoff point, build operate, turn rate, hold angle, start and drop, true vertical depth, TVD, target, displacement, azimuth, vertical sections. Quadrant, polar coordinates, rectangular coordinates, end of drop, tangent section, measurement depth, well inclination, end of build, horizontal displacement, drop of rate. I will let you, I will show you a well displacement operation that how it being done between all disciplines, and it is a teamwork operation.
We are going to drill a challenging horizontal well that we must place precisely in the pay zone. We will use Halliburton's digital asset framework that will give us the connectivity between geology, drilling, and engineering databases. This will help us work across functions as the well is drilled. We will also be doing well bore placement in the digital asset environment. We'll use multi-well geosteering service to calculate well trajectory in real time, referencing data from all relevant offset at wells. We will also continuously update the geological model of our reservoir as we are drilling.
We have the seismic cube from Landmark up and running, so let's see where we're going to place this well.
The objectives with this well are to stay as long as we can in the pay zone, stay away from the unstable shale roof, and also stay minimum 5 meters above the oil-water compact.
Sperry's advanced drilling, LWD, and geosteering solutions will help us with that. We will use the GeoPilot rotary steerable system at bit gamma.
He's talking about RSS, rotary steerable system, that we have a colleague asked and he was looking forward to hear about it from us. It has separate section and we'll talk in details and other
Drilling,
terms.
LWD, and geosteering solutions will help us with that. We will use the GeoPilot rotary steerable system at bit gamma sensor for full geosteering flexibility, the Insight ADR sensor for deep looking azimuthal resistivity, ALD and CTN sensors for our azimuthal density and neutron measurements, BAT sonic tool for rock mechanics and synthetic seismogram, and geotap tester for accurate formation pressure while drilling. We will use Sperry's electromagnetic telemetry service for fast and reliable data transmission. We will also need the Stratosphere 3D multi-well geosteering package to tie our real-time LWD data to the pre-well geological model of the field. This will help to place the well accurately in the sweet spot and update the model in real time while drilling.
I've done the modeling for different drilling scenarios, and I'm confident we can geosteer this well very accurately.
I'd like to know the formation pressures as soon as possible. Let's move the geotap sensor in front of the BAT sonic tool.
It looks like we have the right technology selected for this well. Let's remind everybody to ensure we continue to keep a high level of focus on health, safety, and environment and drill this well safely and to plan. Let's start drilling.
The GeoPilot works very well. I can steer it in any direction I want. With the downlink unit, I do not need to stop drilling to communicate with the sensors. My optimal weight on bit, torque, and RPM are calculated by Max Drill drilling efficiency software based on our formation type and rock strength.
We're drilling through a laminated shale section. Look at the density neutron log. These laminations have a great crossover. We have to revisit these thin sands on the way out and take pressure readings with the geotap tester to check for pressure and connectivity to other parts of the reservoir. This can mean additional reserves.
We should be approaching the reservoir soon. According to the seismic and the synthetic seismogram from the BAT sonic tool, we should be there in 50 feet.
The ADR sensor has started picking up something with high resistivity coming in. You can easily see it from the separation on the geosignal measurement that the sensor makes. This is a sign we are getting close to the reservoir.
I am downlinking to the GeoPilot tool and adjusting the angle of attack.
We have a 50 feet thick reservoir. I want to stay close to the roof and avoid the water layer below us.
The pressure while drilling measurement indicates we have excellent hole cleaning, so let's increase the ROP a little and monitor the data. Are you okay with the data gathering if we increase ROP?
Yes, we have a good data flow, so that should be no problem. My low gamma ray indicates good reservoir properties. Also, I can see a nice crossover from the density in the neutron. Looking at the separation, it seems like we're in a good light oil-bearing part of the reservoir. The average resistivity from the ADR sensor reads about 50 ohm. That's exactly what we expected from the offset wells we've drilled in this area.
Let's use the deep reading resistivity to approach the roof closer and drill parallel to it. Looking at the distance to bed boundary, we are approaching fast.
The geosignal measurement now indicates that we are approaching the shale above us. I want to stay about 5 feet away from the shale. It should be easy if we monitor the separation on the geosignal and also the resistivity values.
I can see the roof is getting closer. Let's hold it at 90 degrees and watch the geosignal to track the roof. Based on the information gained so far while drilling this formation, we can make updates to the pre-well geological model in real time. It will allow us to adjust our well plan on the fly and better plan future wells in this field.
The shale is differing more than I expected in this area. Let's steer down to avoid it.
We're getting closer to the oil-water contact. If you look down now, you can see the water about 13 feet away. Let's change the angle to 92 degrees and move closer to the roof. It looks like the formation is pitching out.
This is the best well we have drilled in this field. We managed to safely finish 5 days ahead of schedule while placing the well in the optimal location. With Sperry's ADR sensor, 18 feet depth of investigation and well placement in the digital asset technique, we kept this well in the money. This will show in the daily production rate when we bring this one online. We effectively worked as a team steering the well in real time and learned a lot more about our reservoir with this approach. We'll definitely apply it to future wells in this field.
Okay, guys. We talk about placement of the well and how it is nowadays with RSS. It's so easy, especially you have a same formation that we have the cap rock in near the bottom of the reservoir, and if we have water down the reservoir, we are afraid to intersect the water, and we don't need to intersect the cap reservoir or the gas bearing formation at the top of the reservoir. We need to go in a same formation. This helped us very much, the RSS one. Now we will talk about rate of penetration because the time is going faster and faster. What is the definition of rate of penetration? The speed at which the drill bit can break the rock under it and thus deepen the wellbore. This speed is usually reported in units of feet per hour or meter per hour, feet per hour or meter per hour. Applications of ROB measurement. We have that bit selection. ROB logs will help to choose the best bit type with appropriate mechanic and hydraulic parameters. We can enhance the ROB by select the right bit for this formation to be drilled with. The correlation, the ROB log is the first source of data that can be used to correlate to nearby wells. This is done by comparing ROB to gamma ray or SEB that was previously used, and it's rare to be used now. This correlation can help determine structural and stratigraphic positions and is used to predict when the well will reach a zone of interest. Our colleagues that are working geologists, our geologist colleagues know this exactly, that he can make in the rig site a correlation for the formation, and he can expect that we have intersect and entered a new formations, and the only parameters that have been reached until this point is the ROB. If he found a break in ROB, a difference in ROB between while he is drilling a formation, so he expecting that we are entered a new formations with different parameters rather than the one was being drilled. So he started to correlate the stratigraphic columns with his well with another offset well, and before the gamma ray sensor reaches this penetrated formation, he can determine that we have entered the new formation, and the only parameters available in his hand is the ROB. Also, we can use the ROB as an early alarm for a kick if we have a break and a fast ROB without any reasonable reason for that. We should stop drilling and observe the well, because it could be an alert for a kick for abnormal pressure. Mud weight adjustment. The drilling rate of shale is very sensitive to the pressure balance between the shale and wellbore. Shales drilled under balanced are characterized by fast drilling, high gas reading, and large cutting. Shales drilled over balance are characterized by slow drilling, low gas readings, and small cuttings. Recognizing these relations can aid in selection of mud weight to optimize drilling speed. Lithology. Shales generally drill slower than sandstones or carbonates, and as a result, ROB logs tend to reflect indirectly the lithology of the formation as we had said. We have parameters that affecting the ROB. Every day morning, you will find that the drilling managers and team leaders, the first points that they are looking for after reviewing the safety is the ROB. They are aiming to have the maximum ROB to reach the TD of the well safely. So we have variables and we have parameters that affecting the ROB. We have environmental parameters which we can't play with it. We can't change it, like depth, reformation parameters, and the mud type in many cases, but we can change the mud type, mud density, and other mud probabilities. Mud density, as we are talking about, that we have reached the safest mud density that could control the formation pressures for every formation being drilled. Other mud probabilities, overbalance mud pressure, bottom hole mud pressure, bit size, because we need to reach the well end with a definite size that will be affected the production tubing, which will gain me the required and the target production. We have controllable factors that affecting the ROB. We have bit wear state, we have bit design, we can select a different type bit, weight on bit. We can play with that. We have the rotary speed that we can increase, decrease. We have the flow rate, bit hydraulics, bit nozzle size, and motor turbine geometry. These are parameters could be changeable and we play with it. Fundamentals of teamwork and team. Now we have the drilling rigs team. We have the rig manager, which is the goalkeeper, and we have shale shaker hand, HSE, Derek man, assistant driller, mud logger, direction driller, DD, mud engineer, roughneck, and in the front of that, the tool pusher and the driller. And the one who is coaching all of that is you, is the drilling supervisor. On other words, the well site leader. We are using this expression, which is equivalent to drilling supervisor, which is a well site leader. In our countries, you are calling him company man. Now, I need to show you something and a video that emphasize you and to you keep always in your mind that you please don't underestimate any role of your team member. Don't underestimate any team member efforts or input or participation. I will show you this video to who are loving football games. I'll show you in another place. Just a minute. Please don't underestimate any of your team efforts. I don't know, it is not found. Let me check. Advanced I'm trying to share you this one is very important video. Let we say this one. Mm, Anyhow, I will share this with you later on, but let we complete with that.
It's okay. We can share it with the material engineer stuff.
Yes, yes, I'm trying to return back to the presentation itself. Is it shared now?
No, it's not.
Fine. What about now?
It's loading. Yes, we can see it.
Good. Now we have mentioned we are trying to hit many items, and it could be declared in details after that. We have mentioned that one main parameter for to have a successful drilling optimization is the rig itself. To have the fit for purpose rig is a very critical clue to have a successful, achievable, a benchmark, a technical edge drilled well. I will share you with the material with our colleagues in the society. I will share you a file that regarding auditing an oil rig that contains more than 170 items. You will find that it is classified as critical, and this is the definition of critical, and major, and finally the minor recommendation. You will find that critical recommendation are based on shortcoming, which may lead to loss of life, a series of energy environment damage, a result of inadequate use and or failure of equipment. And the major recommendation that are based on shortcoming, which may lead to damage to essential equipment or have a detrimental effect on the drilling operation as a result of inadequate use or failure of equipment. Minor recommendation are based on shortcoming may be lead to situations that contributes to an incident or circumstances in which required standards of operation are not met. By the definitions, anyhow, if I say to you that you have a car, okay? If we have a car and you have a problem with the brake of this car, you could classify it by the engineering sense. This problem related to the car brake is critical or major or minor? Any contribution? You have a car and you have a problem with the brake of this car. It doesn't work. You can classify this problem with this car as a critical or a major or minor. Critical, exactly. Exactly, Mahmoud. This is critical. This is exactly what is the sense when you are dealing with the findings that you find in a rig. As much as the critical found and the critical points is higher, and you can't start until this critical points could be solved and solved from the rig. The major, and you give them a time frame narrow, and if you have a major, you can extend this time frame to be solved. And in minor, you can start your operation with this rig, and they can work in that while drilling your well. And this is an actual rig audit. You will find that for that well, we found more than 80 critical points, and they solved almost 20 of them, and the remaining is near the 60 points. And the major was more than 70, and they solved exactly 20 points, and the remaining is more than 50. In addition, the minor was near to reach 20, and they have solved more than 15, and the remaining is more than 15 because they have solved almost 5. I will share with you an actual audit file, and I need to read from your side to read it in details, and we can determine another sessions to explain what is not clear for you. You will find that person involved in drilling a well is multi-disciplines, multi-persons, multi-boxes, multi-titles, and all of this should to be work in harmony in a teamwork to have such result. Now we will talk shortly. If I think the time is so limited to have a break. In usual we have a break at this time, but we talk about underbalance. What about 5 minutes break? Engineer Adel, do you agree
It's
about
okay. We can have a 5 minutes break.
5 minutes break? Okay.
Okay. Okay, no problem at all.
Okay. Okay.
So we will back in 7:25 p.m. GMT plus 3.
Exactly.
وعليكم السلام ورحمة الله وبركاته.
I hope the precision have been shared now.
Yes, it's clear.
Fine, we will talk briefly in underbalance drilling. What is underbalance drilling? In underbalance, we will talk and we'll shift a little bit towards the new applications and the new technology. The first of new technology that we'll touch in brief is underbalance drilling. In underbalance drilling, the hydrostatic head, as we have talked previously, of the drilling fluid is intentionally designed to be lower than the pressure of the formation that are being drilled. The hydrostatic head of the fluid may naturally be less than the formation pressure, or it can be induced by adding natural gas, nitrogen, or air to the liquid phase of the drilling fluid. Whether the underbalanced status is induced or natural, the result may be an influx of formation fluid that must be circulated from the well and controlled at the surface. This is if I have a formation pressure 5,000 and if I have an annulus pressure 5,500, this is called what? Underbalance or overbalance pressure. We have the formation is 5,000, which is less than the annulus pressure is 5,500. This is called overbalance drilling. If I have a formation pressure is 5,000 and the annulus pressure, which is the hydrostatic pressure, is less than 5,000, so it's called an underbalance drilling. Why we use underbalance drilling? The reason for underbalance drilling can be broken into two main categories: maximizing hydrocarbon recovery and minimizing pressure-related drilling problems. In underbalance drilling, we are using many surface and many crews. We are using guidance system to guide us at this time. We are real-time data acquisition that transfers real data, and we have compressible fluid engineering and drilling chemistry. We should be aware of that. We have rotating pressure and rotating head. We have computer modeling. We have compressor air nitrogen supply to be drilled into the drilling fluid, and we have surface pressure handling system. In underbalanced drilling, you will hear for the first time, while you're engineering studying, we heard before in production material and in production sections that we have two-phase separator and three-phase separator. Two-phase separator in production are separating fluid and gas. Fluid is a one stream, oil and water, and the three-phase separator is separating oil and water and gas. Now, in underbalanced drilling, for the first time, you will hear that we have a four-phase separator that's separating like traditional separator of production, oil and water and gas. In addition to, we are separating here cuttings. We are using cuttings to be separated at the surface. Okay, you will find that by years underbalance drilling is getting more and more and increasing. Add a percent of all the drilled. This is for the United States from 1994 until 25. The number of drilling wells with underbalance technique is getting more and more because the advantage of that. And this is the scheme of our drilling fluids. We have the mist of air and the mist, and we have a stable foam. And as we increase the fluid and the water phase in that, in that drilling fluid, as the specific gravity is being increased, you will have that oil is between 6.98 and 8.34, and we will find that saturated and the calcium carbonate until we reach the weighted mud with barite, and we can reach 20 ppg, pound per gallon. As you increase the fluid phase, this is the liquid phase, and which it has this gas 100%. As the liquid phase being increased, as the density increased and increased. Casing while drilling, I need to show you some videos that will explain this slide. As they are saying, a photo is worth than thousands of words, and video is worth than thousands of photos. This is the real operation for casing hole drilling. We use a surface tool. Now he is reaching the end of the joint of the casing. He will pick up from foot, and then he will close the slips, which is catching the casing joint, and will retrieve the running tool, CRI. We will go upward, having with him the new casing joint. I expect that all of you know the traditional way of drilling, that using the bit, connecting to a bit sub, connected to a drilling collar. Is connecting a new joint of casing now.
Excuse me, Engineer
Yes.
Safot. The video is a bit laggy, so if you could explain it in slides, it would be perfect.
Fine, I will try to do that. But it will be so easy to be understood if it is in a video, but we will do our best.
Okay, you can send it in the material, and I will share it with the OPA interns. Okay, it's okay.
I will do it for sure. I will do. You will find that in casing wire drilling, we have a tool at the surface that are connecting to the casing joint, and we have a slips of it to catch the casing. We have two types, one of outside and one and the other one inside, and start to rotate the tool. If we have a top drive, it's connected to it, and the tool started to rotate the casing, and the casing have an attachment by the end of it. This is the tool. Casing get attached by the end of it with a bit, and we have two categories. With the first section, revolution, what the casing welded to with a bit was welded to the casing, and there is no possibility to retrieve this drilling bit. And the worst thing was to reach not to reach the TD with this bit, because we forced it to retrieve the bit which was not applicable at the beginning of this revolution. After that, it have been changed to a retrievable bit, and we can retrieve the bit if we couldn't reach the final section TD. After that, the revolution have been established more and more, and we have this one, and we have BHA that we can have BHA retrieve also the bit. It have been modified, and we have a directional BHA that if we can drill and we need to change either the direction BHA or the bit, we can retrieve it. But the question that will be raised, how we can retrieve the bit that have a hole is greater than the casing, because it goes without saying, and it is with the sense that the hole the casing will run in should be bigger than the casing itself. And we have drilled this bigger hole with a bit. So how we can retrieve this bit from the casing? The clue and the maybe answer is that we have behind the casing a well opener. We have a reamer here. Opener open the well to a larger ID more than the bit itself, which can run the casing. When we start to pull out of the casing, inside the casing with this BHA, these knives of the opener get into profile, and we start to pull out of hole. This is the surface one, which is the look assembly. This is, I could show you some of this. And now we will jump to another item which we could also talk in this in details. After that, we have the HBHD wells. We have matrix for that. We have in the X section is the pressure and for temperature for the vertical one. And we have a cutting edge for each one. And each one, this is the definition for Booker Hughes, and you will find a definition for Schlumberger, and you will find the definition for BB. Both of them are slightly different, but they are identical in the pressure. They have little difference in temperatures, and we have challenges for drilling HVHT wells, high pressure, high temperature wells, because we exceed the limit of the new technology. You will find that this is a matrix for the HVHT wells, and how we reach it. You will find that there is many areas that need to be work on it inside the laboratory and R&D, research and development, and we will find little areas that have been solved related to the HVHT wells. For example, the LWMWD, we will find that the storage have been in the area of the solving, and we will find that telemetry for open hole logging. Many of the available tools nowadays can't be compatible with the high downhole temperature, and sometimes we are forced while we are making a logging to log a section, and we couldn't complete all the section, so we pull out the tool for a certain depth to be cooled, then we run it again downhole for the sensor to work, because the temperature affected on their accuracy, and can lead to damage for this. But this, you will find that the message of this slide, that a lot of area for many drilling equipment need to be adjusted and we need a revolution to compete and to be compatible with the HBHT wells. You will find that when we are talking about HBHT wells, we need to work at this slight area. We need the maximum of the design, we need the maximum of the technology, we need the maximum of the people should be competent for the highest level available, and all of intersect of these three categories should be available for the HT wells. Now we have the challenges for the HT wells from many areas, and the most critical area is the well control. We have primary well control and secondary well control, as we have mentioned in the first of this. We have primary, we have overbalance mud, and if it is have been failed, we have the casing, we have the BOB, and so on for intervention. This is the types of barrier for every phase of the well life cycle, as we have mentioned. And this is a very famous, this is the cheese, Swiss cheese. If we have all the holes aligned together, so the event will be ended with a fire and spill. And this is exactly what happened for Macondo. If you know Macondo and you remember Macondo, they make it a movie film. It was the Macondo was the name of the well, and Deep Horizon was the name of the semi-sub drilling rig, which have catch fire and resulted with one of the most dramatic accident recently. And you should know that life is balanced between risks and benefits. I need to show you this is not also available, but this was a photo from a condo. It was 20 April 2010, and this is the risk of the high pressure, high temperature well. It can suddenly be changed into a catastrophic and something that is very sad. This is, you will find that, and you will find that in the magazine, in the Guardian, they mentioned that BB have lost, according to this event, more than $65 billion. More than $65 billion have been lost due to this event, and the American says the principal saying that they were lucky because the responsible for that was a big company, because it can cure the consequences. If was a small company, it was hard for them to cure the losses. Now I need to you, and some of you have mentioned the drilling problems, and I could guarantee that most of drilling problems could be solved by listening to the well. As we always says, mud is blood. And if you good listener for the drilling event and for your well, you will achieve your goal easily. I need to show you how good I hope work it. I will send it to the with the material. Like that. So you need to be a good listener to understand what is your easy way to achieve your goal. And now we have reached the end of this summary for our session today. And this is my contact is for any related questions or clarification or more explanation. Please don't hesitate to contact me. I have a WhatsApp application for in this number. And if you need to contact me by email, you are most welcome. And I will do my best to answer your questions. And I hope to see you, inshallah, all of you from different countries in next session, inshallah, with our host, inshallah. Now, Engineer Adil, we almost finished, and I think that in Egypt, the Maghrib have been being the time for that. So I appreciate if we could close this now.
Okay, thank you, Engineer Safat, for this wonderful session. We will receive the attendees' question in the WhatsApp group, and I will send it to you, and hopefully you could answer them and send them back.
Inshallah, for sure, for sure. I will do my best to be on time, inshallah. Don't worry. Yani, if you want to contact me 24 hours, for 7 days, you are most welcome, inshallah. I hope
Okay,
that we have
thank
an
you.
interesting, it's almost 2 hours today together, and I know that we have touched everything briefly, and every item have in depth another sessions إن شاء الله. والسلام عليكم ورحمة الله وبركاته.
Thank you. And thank you all for attending.
Yes, for sure.
Hope to see you tomorrow, inshallah.
إن شاء الله. السلام عليكم.